Hello everyone. In this video I will be showing you the inside of Buchholz relay. This is a Buchholz relay. In fact, see, it looks like this. You know that the float that we were talking about, this is the one. This is the float. This is for alarm, this is for alarm, and this is for tripping. Okay, because the Buchholz relay is like this. This is how it looks inside. Normally we used to see only from outside. It looks nice, but then when we open inside, it looks like this. So I'll explain one by one. So these are the terminals. These two are for trippings. These two are for trippings. I mean, for this, if this one fall down, like now, because right now also it is falling down because it is in the air, there is no oil, it is falling down. So these two will be shorting. If I test with a multimeter, these two reds 4 and 5 will be shorted, and this blue also, it's for tripping. If I test now, because there is no oil, they'll be shorted. But this one is for alarm. These two terminals is for this one. Okay, so this is how it looks inside. We have three sets of NCs, because we, 3 sets of NOs. We don't need NCs in Buchholz relay. We need NOs only. So 1 set, 2, 3. Okay, so we have 3 sets of NOs contact. And this one, this is push button. This one is for actually testing the electrical connectivity, the electrical or the circuit diagram, the connection is okay or not, for testing the relay. Like we used to do once a year. You have to just open this and then press this. For initially, when you press this, your this one alarm will short. When you press, you keep slowly, will short first alarm, and then your tripping will also short. Because when I press this, inside there is a spring like this, when I press this, it will push this one down like this. See, it is pushing down, and then after pushing the alarm, it will push the tripping also. For example, if there is oil, this one will be lifted up like that. So if I push, it will go down. Yes, it is going down, right? So this is how. So mostly in Buchholz relay, they use this mercury switch, but in this case, like they use in all power transformers, Buchholz relay use in all power transformers, they use this magnetic switch because it's quite reliable. This is the magnetic switch. This is the contact inside. We have one fixed contact, one moving contact. The moment this float fall down, yes, it will, this magnet will be in this position, closing the switch. See, right now it is in normal operation. Once there is a fall, this will fall down like this, so it will close the switch. It will attract actually the magnet. It is like this. It will attract normal, then fall, normal, fall. Same thing with the tripping also. It is the same only. Normal, fall, normal, fall. So the it will sit inside. I'll show you. It will sit inside. I mean, this is towards the conservator. Conservator is the side on the right side. So if there is a sudden disruption of oil, this one will also move along with the oil, pushing the suppose, because in normal condition it will be like this. Once the oil disrupt, it will suddenly rise and flows towards the conservator. It will push the float down, thus shorting the contact, because then this will come down. This will come down. If it come down, it will close the switch. Here is magnetic switch, lightwise, because we have got actually 2 here also. So this is how it looks inside. It actually is like this, and this terminal, I mean this petcock, this one, it's used for injecting gas, just to test the relay works or not. For injecting gas, you can inject just like you put air in your tire. This is how it, you can close this also. I mean, you can close using this closing, because when it is installed, this one need to be closed, whereas the other one, yes, this one also needs to be closed. This needs to be closed. So it is now closed, and this one is for releasing the trap air. If there is any air inside, I mean, it can be released through this. You have to just first remove this, and then after removing this, you can release the air, okay, from the top of the Buchholz relay. Then after releasing the air, you can close again and then close this, just like you fill SFS gas in GIS chamber. You close this. Yes, so this is how it looks inside. Means in normal operation, when there is oil inside, no, both the float will be up, because the float has been selected in such a way that it is heavier than air and it is lighter than oil. This float these float have been selected in such a way that they are heavier than air and lighter than oil, so that if the oil level falls down because of fall, the air will occupy this position, pushing the oil down. It will push the oil down. And because of this, initially this will fall down, giving alarm, and then second, if there is severe fall, then this will also fall down, giving trip command. All right, so it's very simple the way they have constructed. This company, it's Sedaspe. The company is Sedaspe. Where is it? I'll show you the thing also. Sedaspe. So now I'll restore everything. This is how it sits. I can test the connectivity also. In normal operation, normally you will see like this. If I go to connectivity, yes, now see because it is actually down, the float is down, this is also down, all are down, so all are shorted. I test this for alarm, short, because it is in the air. Now in normal operation, both will be up, like this, so there is no connectivity. For example, if this is alarm, right now it is giving you connectivity. The moment I lift this, when there is oil, this will be up. Now let me do nicely. It's difficult to do alone. Yes, I mean, if there is air, the moment there is oil in normal operation, this will be up, so the switch is not on. The moment there is a fall, it will occupy this position, this where I'm holding air will occupy this, and the float will fall down like that, giving you alarms. Then same way with the trip also. If it is in normal condition, this is the position of the switch. This is the position. This is for tripping. In case a severe fall, now this is a normal position. Now in case of severe fall, the air will push this down, so this will short. Okay, so this much I think it's easy to understand. Now I'll assemble this. Buchcholz relay. I'll assemble this. So for assembling this, I will put inside this chamber. This will go like this. It will go like this. It will go like this, and then I can screw. So this is the Buchcholz relay. This is how it looks like. You must have seen that it has been installed many times in power transformers. So you look from a distance, this is how it looks like inside. This is how it looks inside. This is actually, the whole thing is filled with oil, and you can see outside also, I mean, the oil level, how much is when it operates. Actually you will see that the oil level, I mean, if it fall down below like up to 350 or 300, then your trip, your alarm signal will operate, your alarm contact. And if it still fall below this, then your trip will operate. You can see the float from outside only. I mean, it's easy to understand. This is used in transformers of rating 500 kVA and above. And for taking out the oil sample, if in case it operate, this is from this you can take out. So this is the relay. It's easy to understand, and the connection you can give from this pipe. So this is the Buchcholz relay, the assembled Buchcholz relay. The company is Sidaspe. It's quite good. One thing to be noted, this model is EE3 MG. Serial number also is given there. So the company is Sidaspe. It's written over there. You can see Sidaspe is quite good. I mean, I already opened inside. It's an Italian base relay. So one thing to be noted, that it is the setting for this is that if the air trap inside, if the volume of the air reaches 250 centimeter cube, or if it falls below this or at this point, then your alarm contact will get activated. So this is what we know about this relay. It's not that heavy, this because this is actually an aluminum alloy casting. It's not very heavy, aluminum alloy casting, so it doesn't get rust also. I mean, this is how they make relay. So this is the Buchholz relay. This is how it looks inside. You can see from both the windows, glass window. I mean, it is already, the arrow is there that conservator should be this side, right hand side, and the main tank on the left hand side. And like this flag here is actually, it's for the sudden rise. If there is a sudden rise of oil, then that also will trip the breaker, because then this will push this one. No, it will push this this blade here. It will push this blade here, and then it will trip the breaker. So this is how, I mean, it's easy to understand Buchholz relay. It looks complicated when you read from books, but you know, having your actual relay just in front of you, it's not a very complicated things. So this much. Thank you.